All right. So here's another very common interview question asked in the big tech companies, right? So in this particular question, we are given an input array, right? And what we need to do is we need to find out if there are three such numbers which are present in this particular array, which actually sum up to the target variable, which is another variable given in the input itself, right? So for example, in this particular input array, if you see, there are three numbers 5 here, 7 and 8, which sum up to 20, which is the target, right? And hence my output will be true over here. If I'm not able to find three numbers from this particular array which sum up to the target, then I will just output false. So that's the question entirely. Now maybe you can just pause this particular video and try to think of a solution. Also, we have already solved the two-sum problem in the last video, and I will also link that particular problem with this particular question. So you can just try that particular problem, and over there we actually used a hash map to solve this particular question. Now maybe you can just pause this video and try to think of a solution and think that would hash map make sense over here, or should we do something else, right? And even if we are using hash map, then what is going to be the exact algorithm that we are going to follow, right? So once you are done, you can just come back and check the solution, right? Okay, so now to start with, what we will do is, first of all, we will sort this particular array in the ascending order, right? And once we have sorted this particular array, it will actually help us to efficiently use the two-pointer technique, right? And what is this two-pointer technique? If you don't know about it, don't worry about it. We will be discussing it in detail, like what we are talking about. But just as a matter of fact, this is a two-pointer approach solution that we are going to discuss. And two-pointer works very well with a sorted array, right? So that's why we will be first of all sorting this particular array, right, in the ascending order. So after sorting it, this is how the array will look, right? Now what we will do is, now we will iterate through this particular sorted array, right? And one by one, as we are like traversing this particular array, we will keep fixing one element at a time, right? So one element wherever I am currently at, I will fix that particular element, right? And now for that fixed element, the goal will be to actually find two other elements whose sum along with this fixed element will be equal to the target. So for example, if I am fixing this particular element to start with, right, number one, then I will actually look for two other elements in this particular remaining set of elements in the array, which along with this particular fixed element will sum up to the given target, right? So that's what the approach is, right? So now what we will do is, we will first of all, in the first iteration, as I'm looping over this particular array, in the first iteration, my current element will be this. So for example, I will just say the current element to be pointed by the I pointer, for example. So my I pointer will be over here, right? And now what I will do is, now I will actually assign two more pointers. One will be the L pointer and one will be the R pointer. And this L pointer will be actually pointing to the very next element, to the current element, current fixed element, right? And the R pointer will be at the end of the array. Now let's try to visualize this a little better, right? So if you see this, I have the I pointer over here. L pointer is just next to the current I pointer to begin with, and the R pointer will be at the end, right, to start with, right? Now what I will do is, now I will calculate the sum of these three elements, right? Array of I plus array of L plus array of R, right? Now if the sum actually equals to the given target, we can actually declare that we have found a valid triplet and we can return true right here itself, right? That's what we can do if the sum of these three elements becomes equal to the target, right? But if the sum is actually less than the target, then what we have to do is, we have to actually increase the sum now, right? So of course my I is fixed right now, and keeping the I fixed, I need to find out if there are two such elements in the remaining array, which along with this particular I element sums up to the given target, right? So over here, if you see, now my current sum for these three elements come out to be 11, right? But my target is 20. That means the current sum is actually lesser than the target, and so now I need to increase the sum, right? So what I can do is, I can move this L pointer towards the right, because see, we have already sorted this particular array in the increasing order, right? So if I want to like increase the sum of these three elements, what I can do is, I can move the L element to the bigger element towards the right, and that will actually increase the sum, overall sum of these three elements. And then again, I will check whether that is equal to target or not, right? And in case, my sum is actually lesser than the target, then I would actually move my R pointer towards the left. Because see, again, now I have to decrease the sum since my sum is actually greater than the target, right? So I will just move my R pointer to a smaller element and reduce the overall sum, right? But over here, if you see, since my sum is actually lesser than the target, I will move my L pointer towards the right. And now it is at 3, right? And now my current sum comes out to be 12, which is still lesser than the target, that is 20. So again, I will move my left pointer towards the right to increase the sum, right? And now it becomes 13, which is again lesser than 20. So again, I will move my L pointer towards the right. Now it becomes 14. So again, I will move my left pointer towards the right. Now it becomes 16, right? Which is again lesser than 20. So now again, I will move my L pointer towards the right. But now at this particular step, my L pointer will actually become equal to my R pointer. And that's where I have to actually break out and go to the next number, right? And fix that particular number, right? So now if I go to the next step, it will be that I will be now fixed at the second index, which is index equal to 1 basically, right? And my L pointer and R pointer will be reset back to their original positions, starting positions, which will be L will be equal to I plus 1 and R will be pointing to the last element, right? Now if I check the sum, it comes out to be 13, which is again less than 20, right? The target. So again, I will move my left pointer towards the right and increase the sum. And now if you see, it becomes 14. Again, it is less than target. Again, I will move the left pointer towards the right. Now it becomes 15. Again, it is less than 20. So again, I will move my left pointer towards the right. Again, it becomes lesser than 20 only. So again, I will move my left pointer towards the right and try to increase the sum. But now the moment I will do it, again, my L will become equal to R, right? And that's where now I have to go to the next number and fix I to the next number now. And again, reset my L and R pointers. So I will just do that, right? Now my I is at this particular index, index 2, and L is pointing at I plus 1 and R is at the last index. Now if you see, my sum is 15, which is again less than 20. So again, to increase the sum, I will try to move my left pointer towards the right. Now the sum becomes 16. Again, it is less. So again, I will try to increase the sum by moving my left pointer towards the right. Again, it becomes 80, which is again lesser than 20. Again, I will move my left pointer towards the right. But again, my left pointer will become equal to my right pointer, and hence I will move my I pointer towards the right now, right? I will go to the next iteration basically. So now my I becomes equal to 3 now, right? And the value at 3 index is 4, right? And similarly, my L is over here, my R is over here. And the sum that I'm getting is 17, which is still less than 20. So again, I will go to the next element. I will move my left pointer towards the right, right? And now the sum that I get is 19, which is still less than 20. So again, I will move my left pointer towards the right, but this time it will become equal to R pointer. And so I will go to the next iteration of I. And now my I will become equal to 4, that is 4 index, the number will be 5. And if you see, the sum becomes equal to 20, which is actually equal to the target. And so now I can say that I have actually found out a triplet in this particular array. And at this point, I can actually return true, right? And in case if I actually exhaust all the elements, after traveling all the elements, I'm not able to find a triplet, right? In this particular array, that means I will just come out of this for loop then. And after coming out of the for loop, I will just return false, that I was not able to find any triplet, right? So that's the entire algorithm that we are going to follow. That's the simple approach. Now talking about the time complexity and the space complexity. See, time complexity, first of all, we are actually sorting the given input array, right? So sorting will take n log n time complexity, right? And after sorting it, what we are doing is we are looping over every element of this particular array, and at every element, we are also looping over all the other elements, right? So for each element in this particular array, we are fixing that particular element, and then again we are looping through the rest of the elements, the remaining elements of the array. So that means the time complexity will be n times, right, for n elements, right? So that will be order of n square, right? So for sorting, it will be order of n log n, and for the entire parsing this particular array to find the triplet sum, it is going to be order of n square. And since n square is of higher degree than order of n log n, the overall time complexity will be order of n square over here, right? And space complexity, since we are not using any extra space over here at all, it will be constant, it will be order of 1, right? So that's the entire solution. I hope you understood it well. And also this is different from the two sum solution that we use, because over there we were using a hash map, right? Now we can use hash map over here also, but that would mean that we will be using order of n space complexity. And even after using hash map, I would just leave this as an homework to you. Just try to think what would be the time complexity if we are using hash map, right? Would it be any better than what we are doing right now, or would it be same, or would it be worse, right? So just, comment in the comment section what would be the time complexity if we go by the hash map approach, right? So that's it. Now let's see the code for this particular solution. All right, so now let's code the solution that we just discussed. So first of all, to start with, I will just declare a function and I will just call it as has triplet sum, maybe like this, right? And this will accept the input array and also the target variable, right? Now what I will do is, first of all, I will just sort this particular array in place, right? Like this. And now I will just capture the length of this particular input array in a variable n, right? Now what I will do is, I will run a for loop in the range 0 to n, like this. And in this for loop, now I will declare two pointers. One will be the left pointer, which will be pointing to the current I element plus 1, right? And I will have a right pointer, which will be pointing to the last element, right? And now what I will do is, I will just run a while loop while L is less than R. And what I will do in this while loop is, I will check if the current sum of the three elements at index I, index L, and index R is equal to target, right? If that is the case, it would mean that we have found the triplet and we can just return true at this particular point, right? And if that's not the case, then what we have to do is, we have to check if the sum, that means this particular expression again, is actually less than the target, right? Now if it is less than the target, I will move my left pointer towards the right, because I have to increase the sum, right? And the array is already sorted in the increasing order. So by moving the left pointer towards the right to a greater number, I'm ensuring that I'm getting a bigger sum, right? So that's what I will do. I will just move my left pointer towards the right like this. And in case, the sum that I'm getting at the current three elements is actually greater than the target, then in that case, I have to get a smaller sum. I have to reduce my sum. And for that purpose, I will be moving my right pointer towards the left, that is to a smaller element, to reduce my overall sum, right? And hence what I will be doing is, I will be doing R minus equal to 1 over here, right? And then finally, if I come out of this for loop without returning true at any point in time, it would mean that I haven't found out any combination of three numbers in this particular input array which actually sum to the given target value, right? And so I can just simply return false after coming out of the for loop, right? So that is going to be my overall solution for this particular problem, right? And again, talking about the time complexity, it is going to be order of n square, because if you see, we have nested loops over here. First we are sorting, this will be order of n log n, right? But then we are having nested loops over here, so it will be order of n square. And of course, order of n square is of higher degree than order of n log n. So the overall time complexity will be order of n square, right? So that's the entire solution. And also the space complexity, since we are not using any extra space over here, it will be order of 1, right? So that's it for this particular question. And now I will see you in the next one. Thank you.